Hi everyone, welcome to Trigonometry. Today we explore lesson 13, Law of Sine and Applications. Number one, let's begin with properties of triangles. We have a triangle ABC. The side A is opposite to the angle A, side B is opposite to the angle B, and side C is opposite to the angle C. For the properties A plus B plus C, that is the sum of three angles, must be 180. The smallest angle is opposite to the shortest side. The biggest angle is opposite to the longest side. And the sum of the lengths of any two sides must be more than the length of the remaining side. We also have two trigonometric identities. Sine pi minus the angle theta is equal to sine of the angle theta. This is true because sine is positive in the first and the second quadrant. Cosine of pi minus theta is negative cosine of the angle theta. Well, this is true because in the first and the second quadrant, cosine is positive in the first quadrant and negative in the second quadrant. When we are looking at a triangle, there are four cases. In any triangle, to be able to solve for the triangle, that is, figure out all the angles and the side. Case one is that two angles and one side must be given. Case two, two sides and one angle, and the angle is opposite to one of the given side. In case three, we have two sides and one angle. The angle is between the two sides. And in case three, three sides are given. The first two cases can be solved using law of sine. The last two cases, we have to use law of cosine. Let's take a look at law of sine. Given a triangle ABC, we have sine of the angle A over A equals sine of the angle B over B equals sine of the angle C over C. Let's prove it. Draw the high edge of the triangle. So when we sketch out a high edge, we have two right triangles. From here, we can use the definition of sine. Sine of A is opposite, not h over hypotenuse B. Sine of B is opposite h over hypotenuse A. Well, from here we see that B sine A equal h, and we can sub h equal B sine A. So this gives us sine B is B sine A over A. From here, we multiply both sides by 1 over B. And this gives us sine of the angle B over B equal sine of the angle A over A. We can get the remaining equality by moving the base of the triangle and to be AC and BC. Let's take a look at how we use law of sine. 3 applications. We're gonna cover application that involve case A and case 2. So in case A, we have 2 angles and 1 side. Here comes the example. To find the distance across an impassable river, a student chooses 2 points A and B on one side of the river, which are 100 feet apart. So here come A, here come B. 100 feet. And this is the river. Next, the student then pick a reference point C across the river so that the angle A is measured to be 75 degrees and the angle B is measured to be 40 degrees. Here come somewhere with C. This angle right here is 75 degrees. And this one is 40 degrees. Using this information, figure out the distance across the river. Distance across the river is this one. It's D. To find D, we got to be able to solve for a right triangle right here. If we pick this to be the right triangle to solve, then we need to figure out the side B. Step 1, find B. From the law of sine, we know that B over sine 40 is equal to 100 over sine of the angle C. B is 100 over sine. Well, we can figure the angle C. That would just be 180 minus the sum of the other 2 angles, 75 and 40. And then we multiply by sine 40. B is, put this in the calculator, and that gives us approximately 70.92. Well, we want the answer to the nearest fit. Usually, round up to 4 decimal places should be good in order to figure out D. So I'm going to use 2 more, 37, and that should be pretty good. Step 2. Once we have B, well, we have the right triangle, and then we can solve for D in the right triangle. By D, there's a relation between BD and the angle 75. That relation is sine of 75 degrees is D over B. From here we see D is B sine of 75 degrees, which is 70.9237 times sine of 75 degrees. And that gives us approximately 69. Pretty nice problem. One more. In example 2, we take a look at case B, 2 sides and 1 angle opposite to one of them. Example 2, a water tower 30-meter tall is located at the top of a hill from a distance of 120 meters down the hill. It is observed that the angle formed between the top and the base of the tower is 8 degrees. Find the angle of inclination of the hill. Pretty nice problem. Let's sketch out the hill. So hillsides look like this. All right. And up there, ta-da, we see that, oh, we have a water tower. And it is 30 meters tall. From the description, we know that there are two angles. One of them is the angle between the base and the top of the water tower. This angle is 8 degrees. The other angle is the elevation or the angle of inclination of the hill. This angle theta here. We want to figure out what the angle theta is. So in order to figure out the angle theta, it belongs to a right triangle. And if we can figure out this angle, let's say alpha right here, then we can figure out the angle theta. So notice that alpha plus 8 degrees plus theta has to be 90 degrees. So the angle theta is 90 minus alpha plus 8 degrees. And this angle theta here is the angle of inclination of the hill. To do this problem, first thing is let's figure out the angle alpha. Step 1, find alpha. Sine of alpha over we know the distance right here. This one. It is exactly 1 only meter. So sine alpha over 1 only equal to sine of 8 over 30. Oh, from here we see that sine of alpha is sine 8 degrees over 30 times 1 only. So alpha is arc sine of 120 divided by 30 is 4 sine 8 degrees. And that is approximately 33.8 degrees. Here comes the step 2. Find the angle theta. That is the angle of inclination of the hill. Theta is 90 minus alpha plus 8 degrees. So that be 90 minus 33.8 degrees plus 8 degrees. And this gives us 48.2 degrees. Very cool problem. Thank you for watching. I hope you found the content useful. Please like, subscribe, help the channel grow. I will see you in the next video.